All right, welcome to the 4.1 quiz area of Polygon's remediation assignment. This is a prerequisite skill. Look at the word prerequisite. It kind of pre-requires you to know something. You're kind of required beforehand. This is what you're kind of required to know before you can solve these kinds of problems that are on the test. You need to know how to find the missing length of the side. For example, this side. And if you notice, this is a horizontal side. And horizontal goes, of course, side to side like this. This is a horizontal line. And just for point of reference, this is not a horizontal line. This is called a vertical line. Wherever there's a horizontal line missing, we're going to use other horizontal lines to determine what that missing side is. I'm going to change the color code though for a certain reason. You'll find out why in a moment. We're going to make this one green down here. See, this is a horizontal line that we have the information for to help us figure out the missing piece, like solving a crime, solving a mystery. Scooby-Doo, oh boy, give him a Scooby snack, he's ready. So anyway, let's go with blue here. This is another horizontal side. So we got a 6 to help us figure it out, and we have this 10 down here to help us figure it out. And I'm going to make this one yellow. Hopefully you can see this up here, this nice little yellow color. There's a reason for that, and you'll see why. So somebody pointed out in class that if you kind of break it down like this, like if you look at this like a rectangle here, this rectangle here, you will see that this whole thing here is this from this point here. I'm going to make this, I guess, green again with a highlighter. From here to here is 10. This is 10. Here to here. Interesting. Well, if that's 10, okay. This is 6. It looks like you can just something about subtracting, because if you could almost like bring this down too. Here's what you could do. See this? If you can see this, whatever this is, this here is going to be the same length. That's the one that's what we're trying to find is going to be the same length. Aha! So we have 10 is this, and then 6 is this. So something plus 6 has to equal 10. Something plus 6 equals 10. What plus 6? Oh, it's 4. That's got to be a 4. That's a prerequisite skill. And I was going for yellow and blue because yellow and blue make green, and that'll make more sense on the next slide, I believe. Ready? What if it's this? Uh-oh, now they're asking us to find a vertical line. I'm going to go green here. Well, yeah, like a green, like I'm trying to go green, like for the environment, maybe. I don't know. Anyway, yeah. I mean, gotta watch. You gotta, kind of watch out for your environment. Maybe protect it because you're living in it, right? Okay. Anyhow, that's the side we're trying to find. And we'll go yellow. I'm gonna just go right into highlighter mode. No, 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 not. Just kidding. We'll stick with here. This would be 4. The vertical, remember, if we're missing a vertical line up and down, we're going to use vertical lines, up and down lines to help us find the missing up and down line. This will be blue. So we know the 6 and we know the 4 is going to help us figure out that mystery missing side. Okay, so this is what, I think this is actually more in line with what the student was saying in class. Okay, look at it again like this. And if you see this, then you can see that this yellow side here is 4. So this over here also must be 4. And that's going to help us figure this out. And if this blue side over here is 6, which it is right here, then this also must be 6. Are you seeing what I'm seeing? So this time we're doing sort of the opposite. You have 6 here, and then you have 4 here. And 6 and 4 is, dun, 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 10. So the green must be 10. Yellow and blue make green. That's what I was trying to do on the previous slide. Yellow and blue make green. Okay, that's how you find the missing sides. Well, then what? Then what are we going to do? We got to know this prerequisite squill. What's the area of it? It doesn't say, oh, it says triangle. We're going with a rectangle here. What's the area of the rectangle below? Just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square units. You also may be seeing this listed as 12 units squared. At any rate, what if we have a whole bunch of these things and we don't want to, have to count every single one? And you might not have the squares to count. What would you do? You may have noticed this. You can just do 3. 1, 2, 3 is the length of this side. 4, 1, 2, 3, 4 is the length of this side. Go 3 times 4 equals 12. Ba-ba-bum. What about this one? Oh, this should say it too. Couple mistakes here, fixing them right on in the moment. Okay, this is a rectangle again. Rectangle. Okay, so anyway, what is this? You can count again. 1, 2, 3, 4, 5, 6, or you can say 3 times 2. 6 square units. Okay, what about this one? Uh-oh, no squares to count. Even if we did, that'd be a lots of count-ins. So just do base times height. You also have been taught this as length times width. The reason why I'm doing base times height instead of length times width is because it's going to help us when we get to triangles. So at any rate, base times height, 10 times 7. 10 times 7 is 70 square. You don't see, well, there's no squares, Mr. Hoffman. You have to kind of imagine them there. That's the idea, square units. Also, it could be 70 units squared. Okay, next. So this is what it would look like if you say, oh, that's where the squares are. You can imagine them, right? This is 1, 2, 3, 4, 5, 6, 7 going this way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going this way. Count them up if you want to, but I'm telling you, I'm pretty sure about that there's going to end up being 70 in there, 70 square units, 70 little squares. One's little square, 2 little squares, 3, and so on and so forth. Anyway, now this is the actual question you're going to get. What's the area of the polygon below? Well, you see where that prerequisite skill is going to come in? Yeah, prerequisite skills. First, you can cut it this way if you want. You could also cut it up and down if you like. You might be able to cut it this way and figure it out. So just for kicks, maybe we should do it that way. Yeah, I think so. And so, but what numbers do we use? Well, you have to be very careful because this 14 is for all of this. And if I want to find just this one right here, this rectangle, that 14 is longer than the actual rectangle. But this 8 here goes right with it. The 8's going to go this line. I can do 8 times this length times width or base times height, however you want to call them, times this 3 over here. And that's going to give me how many little squares would be in here if I were to actually draw the squares. Just pretend like there's 8 and 3. That's definitely not correct. That's way off. At least I want to be somewhat accurate here when I try to show you this. Yeah, if there's 1, 2, 3, 4, 5, 6, 7, 8, you're not going to draw all this every time. Just do 8 times 3, people. Come on. 8 times 3 is, what's 8 times 3? Is 16, 24? 24. Boom. Square feet here, or feet squared. But what about this one? Ooh, okay. So here's our 10. 7. The 7 only goes, remember, the 7's only this line here. And we need the total. We need all of it. So this 10 will be more useful. Take this one here times this, but we don't have that. Oh, this is where finding our missing side comes into play. And if you remember, this 14 here will help us, and this 8 will help us. This is a horizontal line, so use the other horizontal lines to help you. This is a 14, this is an 8. So what's this? You can kind of bring them right next to each other, bring them together. Everybody come together right now. See, that's the question mark, not a 2. That's supposed to be a question mark, not a 2. So just make sure you understand that that's a question mark. This is what we're trying to find, is this one. There we go. Now that's better. And let's clean up that line because it's a really sloppy line. And let's make it, we'll keep it black for now. Like so, something like this. It doesn't have to be exact, just enough to kind of get the idea to help us figure this out. And bring this 8 down here. Yeah, 8. And let's make it so that's blue here. So let's put it blue here. And they are connecting pretty much like this. There's a 8 and then the 14. Oh, it shows it blue here. We kind of like to make it a different color, like, green, for example. So this 14 down here, we'll make that green. So we'll make this one green. And we'll make, there we go. So, yep. So 14, aha. Do you see that? Do you see what's happening here? You can kind of go like this. So something plus 8 equals 14. Something plus 8 equals 14. 8, 9, 10, 11, 12, 13. That's 6. Yeah, we've got your number. So this is a 6 up here. Okay, so then what? Oh yeah, 10 times 6, 6 feet, is going to be 60 feet squared. Then you just add your 60 plus 24. 60 plus 24 is 84. So this total would be 84 square feet for everything. That would be, and just so we can kind of get some color coding so we know what we're talking about, if you take the purple rectangle, which is 60 square feet, plus the green rectangle, which is 24 square feet, you're going to get the total, which is 84 squares, or 84 square feet. Also can be written as 84 feet squared. Okay, wow, that was all number 1. Here comes number 2. Okay, prerequisite skill. Well, we already prerequisite skill. Can I have a prerequisite skill in knowing how to pronounce words? That's a prerequisite skill to teaching, Mr. Hoffman. Okay. Slow down, people. 2 times 2 is 4. All right. 4 square units. You could even count them. 1, 2, 3, 4 squares. Now, that's 4 units squared. What about this? Uh-oh. How do you do that? Oh, that's easy. 2 times 2 is 4. Well, wait a minute here. This doesn't look the same as this. Well, that's because, oops, 4. It's not 4. Don't do that. You're close, though. You're halfway there. By half, I mean, that's the full sandwich. If you kind of use the sandwich metaphor, that's the whole sandwich. Base times height is the whole sandwich. You got to cut it in half. Cut that sandwich in half diagonally, of course, to get the triangle. Yeah, so now that's 2. Take half of what you got there. 2 square units, or 2 units squared. Yum, yum, yum. I can't wait for lunch. Oh, so here, base times height equals the whole sandwich. A triangle is half of the sandwich. So, oh, I know the answer to this one. It's 12, Mr. Hoffman. It's 3 times 4 equals 12. Wait a second. That would be if it were the whole sandwich. We don't have the whole sandwich. Take that 12 and cut it in half. 12, take that 12, cut it in half. Here we go. Oh, so anyway, so what's half of 12 is 6. Divide that 12 by 2, which is 12 divided by 2 equals 6. You can go 12 divided by 2 equals 6. Just saying some other ways of seeing it, okay? All right. Oh, what about half? Oh, we can do half of 12. Half of 12 equals 6. And anytime you see the word of, almost always, I say 99.9999% of the time, of means multiply. So this would be half times 12 equals 6. It goes both ways, okay? All right. What about this one? What is the area of this triangle? Try it out. Triangle it out. How'd you do? How'd you do? Did you get 28? Yes, 28 square feet is the answer. Oh, wait a minute. That's the whole sandwich. Oh, you silly. That's not 28. It's half of that. Oh, goodness gracious, because 28 would be the whole sandwich. We need half of the sandwich. Please remember to cut the sandwich in half when you're doing triangles. Half of 28, this is 14. 14 square feet. Also could be written as 14 feet squared with a little, remember this thing here called x what? Exponent, ponere, put it down. This is, if you did see the squares, this would have looked like. Yeah, if you want to pause the video and count them, go be my guest. Okay, we finished with the prerequisite skills. Now let's get into the real nitty gritty. The question. This is, I believe, a question from the test. It might be exactly the same. I think it is, the quiz rather. So we're going to break it down into its particular parts. This composite shape is composed of two figures. You can see the rectangle, and you can probably see that triangle over there. And oh, notice, if this side is 7, then therefore this side is 7. Opposite sides of a rectangle are equal. All right. Well, if this here is our triangle, okay, so this is 12. Well, if this is 12, well then cross off that 18 for a few moments because that's going to get confusing. We'll come back to that 18 momentarily, but right now, just consider the following. Ooh, see this? If this side's 12, then this side is 12, right? Opposite sides are equal of a rectangle. Now, we need to figure out this side. In order to do this problem, you're going to need to figure out what this is. This is going to, it's going to tell you that's going to be your height. You're like, how could that be height? Height goes up and down, not always. They kind of turn this triangle around on its side there. So at any rate, there it is. 18 is this. Oh, no, it's not 18. 18 is all of this. So what we can do, oh, that's 6. How do I know that's 6? Well, something plus 12. Yellow plus green equals purple. So whatever that yellow is, something plus 12 equals 18. And that's 6. There we go. 6 plus 12 is 18. Now you got it. Okay, here comes number 3. What's the area of the composite figure below? Well, we'll be breaking this down at all kinds of shapes. Well, actually, only one kind of shape, and that's called a rectangle, but there's 3 of them. So anyhow, we're going to find the area of each one of these and add them all together. So you're like, I don't know how to do the area of those fractions. Well, we did multiply fractions. We had a whole lesson on it. But I'm going to say, in this particular case, I'm going to use this little thing that somebody put in the chat yesterday in class. My friend refuses to believe that working with decimals is easier than working with fractions. He is missing the point. In this particular case, I would completely agree with that. I don't think that's always the case, though. In this particular case, we're going to go ahead and do the following. I wrote the down dimensions over here. For green, we have 5.5 times half. 5.5, I would say base times height, because, this is also 5.5 down here. Anyway, 5.5, this 5.5 times this half gives us this area for the green. For purple, 7.25. Oh, good thing we caught that. That's not 7.25. That's actually 7.5 over here, right there. Whew, that was a close one. Times 2.25 gives us the area for the purple. Then, of course, yellow, 1.5. Make sure that I wrote that down right. Good. Times 6.25. Yep, gives us the area for the yellow. You add them all up, and you'll get the total area for all of that that figure below, that composite figure, that composite shape composed of 3 rectangles. You can cut it different ways. I just chose to cut it this way for now. Either way, you should end up with the same answer when it's all said and done. So here we go. Working with decimals is easier. So here we go. Watch this. This is so much fun. We're going to pick a color I haven't used in this particular screen, like this little blue here. The 5 will stay a 5. All right? Boom. And 1/2. So and 5 and 1/2, 5 and there's our decimal. But instead of putting 1/2 here, what is 1/2 as a decimal? Well, if you forget, you can always do this. Numerator divided by denominator. The numerator for 1/2 is 1, the number on the top. 1. Numerator divided by the denominator, 2. 1/2. 1 divided by 2, it's 0.5. So right in here, we're going to write, instead of 1/2, we're going to convert this to a decimal in the following manner. Just put a 5 there. Ta-da, 5.5 times, well, here we go, 1/2 again. 1 divided, now we get to put the leading 0.5. Put that in your calculator, and that's going to be the area for your green rectangle. Next, do similarly down here. We're going to say 7. That stays as 7. Oh, look, 0.5 again. 7.5 for the 1/2 times, 2 and 1/4. And how do you do 1/4? Okay, back to the calculator. Bring it on over. Clear the board. This time 1 is the numerator divided by the denominator, the down number, the bottom number, for 0.25. So we're going to write just the 0.25 part of that there, like so. 2.5. And just so we can clarify what's going on here, what's a color I haven't used? I know, red. This half goes here. This half goes here. This 5 stays a 5, and there's nothing in front of the half. There's no whole number, so that's why that 0 is there. 7 stays a 7, 2 stays a 2. Half turns into a 0.5. This 4 turns into a 0.25. I guess I should include the little decimal in there. Would make sense, I guess. 7 and 1/2. 7 and 5/10 is what that turns into. 2 and 25/100. 2 and 1/4. There you got it. Okay, so hopefully you got this figured out and you could do the same things with these here, but you're on your own with those. I think you got this, and then just add them all up. Remember, this is going to be your purple right here. Whatever you get for this, that's your purple rectangle. And down here is your yellow rectangle, whatever you get here. And then remember, you have to add this up. The green plus the purple plus the yellow equals your final answer in square feet, feet squared. All right, look at all the fun shapes in here. One of these shapes will probably jump out at you right away, and that's probably this rectangle right here. You can see the base is 4, and you could probably tell the height is 5. So we're just going to do a little 4 times 5 equals 20. And I'm just going to keep the 20 out here. I mean, you could put 20 in here, but it's a lot of stuff going to be going in this here. A lot of it gets confusing. So I'm going to keep track of it this way by drawing a kind of a rectangle over here. And you know, I can color code all of this at this point. Yeah, so this is my green rectangle. All right, there we go. So now let's see, what could we do next? Let's try this. There's a triangle here. Let's try the triangle over here. Ha 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 ha. All right, so I can see that remember, the base and the height, it always goes with the right angle. Yeah, I always like to think the height is right. The height is right. So if you have something like this with a right angle, the height is right. In this case, the height would be going up and down. And so we could connect it like this. Height is right. But so is the base. The base is also right. They're both right. How could that be? How could they both be in different directions and still be right? Well, the idea is that they're connected to the right angle. At any rate, whatever two you use, whether you if you want to switch it, just think if you flip this rectangle, let's see if you flipped it like this. Let me see if I can figure this out. That's the long one. Yeah, and let's see, when you flipped it up, that means this would be going this way, right? Am I right? Let me see. Let's try this again. Flip it up. So, oh yeah. So this is here, and this is like this. In this case, the height is right, but here it's the base. It doesn't matter. Base, height, it's whichever two lengths are connected to the right angle, that touch the right angle, those are the two you're going to multiply, right? So, so this could be whatever this is. Okay. In this case, what is it though? Oh, it's 2. So this would be 2, and this would be 5. If you flipped it this way, this would be 5, and this would be 2. You're still going to get 10. If you do 2 times 5 or 5 times 2, you still get 10. So this is going to be here, because this is 5. Why do we know that this is 5? Because this side is 5, and opposite sides of a rectangle are equal. See, 5. So 2 times 5, this would be 10. Oh, wait a minute. 10, is the whole sandwich. 10 would be the whole sandwich. We're not eating the whole sandwich here. We're only eating half of the sandwich cut diagonally. So cut that 10 in half. What's half of 10? That's what goes here. So the whole thing is 10. We're just going to do half of that, which is going to be 5. So we're going to do, we would say 2. 2 times 5 is 10. But what's half of 10? Half of 10 is 5. I'm going to erase this now, make some more room. Half of 10 is 5. And I'm going to slide all this over to keep it in line with all the work that I've done. Like this. And this is one of our triangles. And we color code this blue. Let's erase this so we don't get too confused with all these numbers in here. Blue. And did you notice that we have 2 triangles that are exactly the same? Yeah, this one over here. So now we're going to add another 5. For the other triangle, that's the same as this one. Now we have 2 triangles left. Here and here. So I'm going to add some kind of way to get to that triangle, and we're going to do it twice. So we got 2 more triangles to do. Oh, forgot to color code that. And then we add all of those numbers up to get the total final answer. Okay, so how are we going to figure this out? Well, remember, the height is right, and so is the base. So what are the 2 numbers that are attached to the right angle? Here's the right angle. And here is one that's attached to it. Here is another one that's attached to it. Well, we see this is 3. So there's one of the numbers we're going to multiply. 3 times something equals, okay, well, we also got to take half of it. So let's be a little careful there because it's not the whole sandwich. Actually, it would be a whole sandwich if you think about it, because if this is half the sandwich and this is half the sandwich and we eat all of that, that's a whole sandwich. But so that's a shortcut if you think about it. But anyway, 3 is going to be one of the numbers we're going to get in there. And then, well, what about this? How do we figure out what that is? Well, I can tell you this. See this number here, this 4 and this 4? That's not connected to the right angle. That's extraneous information. Think of the word extraneous. I'm going to write it down for you. See if you could see something in the word extraneous. Ah, did you see it? Extra. It's extra. We don't need it. It's extra. That's extra, extra. Read all about it. These 2 numbers aren't going to help us solve the problem. These 4s are bye-bye. So what do we do here? Oh, yeah. So we know that this is a 4. And we know that this is a 2. So what can I put in here? I'll put like something that'll pop out like a red. See, this is 2. From here to here is 2. And oh, did you notice this is tricky? This is cut in half. This goes right down the middle. Right down the middle. Yeah. So whoa, if this is 4, this would be half of 4, this would be half of 4, which is 2. Right? So let's let's get rid of the 4 for a moment because it's going to be tricky. So pretend like the 4 isn't there. Instead, well, it still is there, but we have 2 and 2, right? Because that's still the same thing as 4. Well, if this is 2, then this is 2. Oh my gosh, remember that this is 2. So how long is this? This is also 4. So this, let's see, a new color. How about, what color didn't I use in here? I used my orange. Nice thick orange. So this here is 4, which is 2 plus 2. So now we know the base. The base is 4 times the 3. Or we know that other number. Base, height, whichever way you do it. The ones that are attached to the right angle, because this is also a right angle. Boom, 3 times 4. But that's, remember, that's half of the sandwich. So 3 times 4 is 12. What's half of 12? Half of 12 is 6. And so we have 2 of those. And this is also 6. So if this is 6, this is 6. Add them all up, and then you got your final answer. 20 plus 5 plus 5 plus 6 plus 6. Dun, dun, dun. Swimming pool time. Who likes to go for a swim? Let's dive right into this. I couldn't help myself. The blue part is the pool. The yellow part's the deck. How many square feet of tile will be needed to cover the deck? Okay. Well, first of all, let's take the pool out of there for a moment. How many square feet will we need just without the pool? 200 square feet. Now, if we bought all 200 square feet, there's all this tiles in here that we're not using because the pool's going to be in there. So what do? We take the 200 and subtract how many tiles would actually cover the pool, but we're not going to cover the pool with them. And so we take the 200 minus 40. Yeah, that's it. 10 times 4, 4 times 10, either way. 10 times 20, 20 times 10. That's how you do it. Okay, so you do the same thing here, but this time you have to find it with decimals. Get the calculator. See that? There it is. 22.25 times 40, got 890. That's the area of the deck for the tile. Now we got to subtract the blue because we're not going to need tile for the blue part. And anyway, that's what you do. Same as before. Done. By the way, it does ask you to, watch this, round your answer up to a whole number. That's this here. We're going to show you how to round up in a second. It's actually easier than rounding to the nearest whole number. You're probably used to rounding to the nearest whole number. First of all, what's a whole number? Well, they mean the ones place, more or less. Let's just kind of look at it that way. The nearest whole number is going to be like right here, ones. So we look at the digit right to the right of that, right to the right. So we're gonna call that the boss, and so we're gonna do that yellow. And so here we'll just go to this purple. That's the one we're rounding. So by the way, this is what we're not doing because this is round up. I just want to show you what rounding to the nearest whole number does look like. You're like, oh yeah, I know that. So the boss tells this worker here what to do. So hey, so if the boss, the yellow one, is 4 or less, the purple gets to stay where it is and not have to change at all. So we like you just the way they are. You can stay just the way you are. Now, if the boss is a 5 or more, then we have to raise the score. That means whatever the purple is has to go add 1 to it. Okay, so let's take a look. The boss is a 3. So where is a 3 at here? Is it in this box? Is it in the raise the score box, or is it in the let it rest box? 3 is here. That means to let it rest. So if we're rounding to the nearest whole number here, the answer is going to be 6, 3. The 0 gets to stay as 0. And everybody else gets to go home, including the boss. Hey, we all did a great job. We all go home. Bye-bye. Good night. Have a good night. 630 is the answer. For this one, though, 7. Where is 7 at down here? Let's see. 7 is in the other box. That means raise the score. The boss is saying, hey, you got to work harder. 6, 3, 1. Add 1 to it. But guess what? Everybody else still gets to go home, including the boss because he's the boss or she's the boss or whatever, right? Okay, so this is the answer. If you're rounding to the nearest whole number. Now, if you round up, you're going to like this. Way easier. All you do, find that whole number again. Let's go with the same colors. Why not, right? But guess what? It doesn't matter what this preceding digit is. It doesn't even matter. The boss has basically been fired. Can you fire the boss? I don't know. You can just quit, I guess. You quit and raise yourself up, I guess. Say, I'm emancipating myself. I'm leaving this job. You can take this job and you know what? Do whatever you want with it because I'm not going to be here. So that means no matter what it is, no matter what this is, we're rounding up. So we raise it by 1, add 1 to it. So this is 6, instead of 630, 631. Instead of 630, 631. Instead of 639, Well, how do you add 1 to that? It's actually going to be 640. Instead of 639, 640. Don't you like rounding up? Yeah, me too. By the way, we got round up. There's a joke about rounding up sheep or cattle or something. Yeah, counting them. At any rate, you've made it this far. You almost had a good cringe joke. Here's the code. Congratulations.